All right, we got question 4 here from our function notation mid-unit 4 test, practice test. Functions R and D give the height and feet of a toy rocket and a drone t seconds after they are released. So I'm looking over here at my graph. The first thing I look at, I want to see how my axes are labeled. It's so important to know what your axis is. So here's my time in seconds on my horizontal axis. And on my vertical axis, I've got my height in feet. So these are my inputs. I can plug in how many seconds have passed, and my output will be the height. And that's what it means when we say that these are a function. They give us the height as a function of the time in seconds that have passed. So here's the graphs for rocket, the graphs of R for the rocket and D for the drone. Write each statement in function notation. So they gave us this little sentence right here. At 3 seconds, the toy rocket is higher than the drone. And I can look at this. I'm going to look at 3 seconds. Looks like the drone is at about 20 feet high, and the rocket maybe is pretty close to 40 feet high. So that's definitely true. Now, how can we write this as function notation? So concerning the rocket, what we're looking at here is the function R, the rocket, gives us the height as a function of time. And function D gives us the height of the drone as a function of t in seconds. So we plug in how many seconds, and our output, or what we used to call the y value, is going to be our height. So let's write this. We're using R of t and d of t. So the toy rocket is higher than the drone. So I'm going to say the rocket, function R, as a function of 3 seconds. 3 seconds have passed. And it's going to have a higher height than the drone as a function of time after 3 seconds have passed. So what this R of 3 right here is telling me 20. Or no, I'm sorry. R of 3 is maybe about 40 right there. And D of 3 is 20, and it's true that 40 is higher than 20. And here is how we could rewrite that sentence A in function notation. Now, how about B? It says, at the start, the toy rocket is 25 feet above the drone. So you know what they're talking about? What's at the start? After 0 seconds, we got our vertical intercepts here. Here's where we're beginning. 0 seconds have passed. So apparently this rocket was launched from an initial height of about 25 feet. Maybe it was up on the rooftop or the side of some hill, but they launched it from 25 feet up somehow. And the drone, its vertical intercept was at 0. It's got this initial height of 0. They must have taken the drone, took off from the ground, and started flying. So at 0 seconds, it was 0 feet high. So how can we write that? We're going to use R of t and D of t. So the rocket, the way I like to write this is say D of t, the drone as a function of time, and how much time has passed. They said at the start. So 0 seconds have gone by. D of 0 plus 25 feet would be equal to that initial height of the rocket, R of 0, the height of the rocket after 0 seconds. Now, there's other ways you could write this. This is not the only way. You could also say that this rocket as a function of 0 seconds equals the drone the height of the drone is a function of 0 seconds plus 25. Both of those are equivalent statements. We've just sort of rotated them, but they're both saying that d of 0 plus 25 equals r of 0. And that's what we're looking for right there. You want to be able to go back and forth. You want to take a sentence and be able to write it in function notation. You want to be able to take function notation and rewrite it as a sentence.